Hello and welcome to this video on using trigonometry to solve for missing sides of right triangles. To begin with, we're going to talk a little bit about what we learned about last time with discovering trig ratios and how we can use them in specific ways. So I want to kind of put at the top of this word problem we're about to kind of preview two things that are going to be very helpful. So the first is a mnemonic device that will help us to remember all three trig functions, and that is a acronym that you pronounce as SOHCAHTOA. I call her the princess of trigonometry, kind of like how Pocahontas is the princess of the forest from the Disney movie. Now, what that means is that sine is going to be opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And so we can write that here. So sine of, and something to note that we have an unknown angle. We are going to be using the Greek letter theta, and that's what we could write there at the top. And we can use that to then have that equal to opposite over hypotenuse. Cosine of theta is going to be adjacent over hypotenuse, and tangent of theta is going to be equal to opposite over adjacent. And now, in addition, we're going to write a little triangle here that we're going to use in association with what we just wrote, in that we're going to have an unknown angle, and then we're going to see a right angle. No, that tells us we're dealing with a right triangle, and we're allowed to use these trig ratios. And so we have opposite because it's the side across from or opposite from the angle we know. Adjacent would be the one next to it. Adjacent means next to. And then the hypotenuse is always in the same place because it is across from the 90-degree angle. Depending on which angle we have, we could be given the top angle here. That would switch which one is opposite and adjacent. Just remember that hypotenuse stays where it is, and then depending on where your angle is, opposite and adjacent could be in opposite places, could be switched around. So we're going to do word problem here as a quick introduction and then move into some more concrete, just algebra trig examples. So the first thing you want to do is read through this problem. So take a second to pause the video and read through the word problem. And your goal here would be to try to figure out what would be our first step and what would be important to note. Now that we've read through it, we want to kind of underline some things that are going to be important. So I would underline 200 feet away. Little boy is saying 200 feet from a tree. The angle of elevation, we're going to be talking a lot about that term later this chapter, is 40 degrees. And the boy's eyes are 4 feet from the ground. So we'll say he's basically 4 feet tall, this child. And we want to know at the end how far above the ground is the balloon. So we want to now use the information we just have there to label our diagram. So the first thing we can label is the boy is 200 feet away from the tree. So this distance right here is 200 feet. Our angle of elevation from the boy's eyes to the balloon is 40 degrees. That would make this measurement right here equal to 40 degrees. And we have the last part is that the boy himself, from his eyes to the ground, this distance right here is going to be 4 feet tall. So that is important, and I believe that we've now underlined everything that we were going to need. So our end answer result, what they're asking about is how far above the ground is the hot air balloon. So they're asking about this whole distance is eventually going to be our unknown. Now, what we're going to do with trigonometry here is we're going to first find how far that distance is. We can give it a different letter like y. And then we're going to add to y this 4 right here, and then that will give us the final answer that we're looking for. So let's get into our steps. First, we want to think about, well, why can we use trigonometry? We need to have a right triangle. So we can assume that this hot air balloon is straight above the ground and it's making a 90-degree angle with the boy looking straight ahead at the tree. So this angle right here, that you can't really see it, but this angle right here is 90 degrees. So we can definitely use our trigonometry. So to work through our steps here, we're going to be looking at our 40-degree angle. The unknown right here, this y, that is the opposite side. And the 200 feet right here is the adjacent side. So the two things we don't know anything about the hypotenuse, the longest side of the triangle, so we're just going to ignore the hypotenuse for this particular problem. Let's start setting up what we have. So we have, because we're doing opposite and adjacent, we're going to use tangent. So I'm going to set it up as the tangent of 40 degrees is going to be equal to opposite, which is y, and over adjacent, which is 200. So now you have an option here. It was when you go into your calculator and type in tangent of 40 degrees, that's going to give you a decimal answer. That decimal answer is what is representing the comparison of the two sides, comparing the opposite side to the adjacent side. It's a ratio comparing those two sides. So essentially, we have an unknown side divided by 200 would be equal to what tangent of 40 is. So we could grab our calculator, and the first thing you want to do is make sure your mode is in degrees, because we're talking about degrees in this problem. Just hit mode and then scroll to the third one down. So then we could put in tangent of 40 and get 0.839. And that would be equal to y over 200. From there, if you were using your algebra skills, you would just need to multiply by 200 on both sides, and that would give you your answer. So we could multiply that answer. We got 4.839 by 200, and our approximate answer would be that 167.82 feet would be our y value. And then you add 4 to it for the boy, and that would be 171.82 feet above the ground. And that would answer the question that we've been asked here. Now, what we can also do, and what I prefer, is not make that tangent of 40 into a decimal. We want to keep it as tangent of 40 so that we can have a very exact answer. So I would take this same first step. I would still have it as tangent of 40 equals y over 200. And what I would do from here is just multiply by 200 right away. So times 200 times 200. And that means that I have in this problem basically 200 times the tangent of 40 is equal to y. So if I go to my calculator, we can see how different our answer would end up being. 200 times the tangent of 40 is 167. So if I had used the rounded version, 0.839 for tangent of 40 times 200, we can see that that is rounded. So it's not quite as exact. And in this case, you only have to go to your calculator once to put it in, instead of having to put it in your calculator twice, which would make the problem a longer one at the end. So we know that our y was 167.82 feet, and that would lead us back to our original answer we got, which was 171.82 feet above the ground. And this is kind of demonstrating a very straightforward example of where trigonometry might be used in the real world to determine the heights of something. If you know the angle you're looking up at it and how far you would be from the point right beneath said object. From here, we can look at advancing into some straightforward algebra problems. And in all of these, we're going to be basically working through our steps to solve for x to the nearest tenth. And we're going to be writing out, well, what would be the trig function that we're working on? And then we'd be kind of solving it from there. So we're going to work through about 7 problems here in this video, starting with what we are looking at in front of us. Okay, problem number 1. We are looking at a right triangle with an angle of 40 degrees, and we have a x and a 25. So in relation to that 40 degrees, we would say that this x would be the opposite side, and the 25 would be the hypotenuse side. So thinking about the picture we drew on our first example, if we don't have anything about an adjacent side and we only have a hypotenuse and an opposite, that would mean we're working with sine. So I could set this up as the sine of 40 is equal to x over 25. And just like last time, now that I've set this up, I can multiply by 25 on both sides, which would divide out the 25s we have. And that would mean that my x value is going to be 25 times the sine of 40 is equal to x. And then we can grab our calculator again, and we can do 25 times the sine of 40, and that equals 16.1, round to the nearest tenth. You can also just type it in as 25 sine of 40 to save an extra button press, and that gives you the same answer. So we got our first problem all done. We found out that x was equal to 16.1. Moving on. Number 2, we have a new angle of 35 degrees. In relation to that 35 degrees, the x would be the adjacent side, and the 10 would be the hypotenuse side. Adjacent and hypotenuse goes with cosine. So we are setting up our problem as cosine of 35 is equal to x over 10. Just like last time, we can multiply by 10 on both sides. So that would mean we have 10 cosine of 35 is equal to x, giving us a final answer of 10 cosine of 35 equals 8.2 for x. So 2 problems, both kind of working pretty similarly. And in this case, you have both of them kind of setting up your trig equation and trig function, and then multiplying by your denominator on both sides to get your answer for x. In problem 3 and 4, we're going to see that change, and we're not going to just have sine and cosine and the x on the top. So in number 3, we have our 44-degree angle on the top left, so it's a different place. In relation to that angle, the 15.2 would be the opposite side. The x would be the hypotenuse side. Opposite of hypotenuse, like in number 1, is sine. So now we have the sine of 44 degrees is equal to 15.2 is the opposite side over x. So right now we can't multiply by 15.2 on both sides to get any closer to our answers. We have to use a different strategy. So to me, the best strategy is do something we're familiar with, and that'd be making it into a proportion. So I would put the left side over 1, and I would be doing 1 times 15.2 and x times sine of 44. That would give us, like I said, x times the sine of 54 equals 15.2. From there, we just have to divide by the sine of 44. So divide by sine of 44. divide by sine of 44. And that would mean that we'd have these two signs dividing out until it become a 1 and leaving us with x being equal to 15.2 divided by the sine of 44. So we can put that into our calculator, 15.2 divided by the sine of 44. And notice how I am putting that into my calculator. You don't need to have any extra parentheses. You can put it in exactly as is. And you can see our answer ends up being that x is equal to 21.9. Now to number 4. So if we have this new problem, we have 23 as our angle, and we have the x is our opposite side, 8.9 is our adjacent side. So we have both of those together, giving us means we're going to be using tangent. So I'm going to have the tangent of 23 equal to opposite over adjacent. And we have that as our setup. So we're going to multiply by 8.9 on both sides like earlier. 8.9 times the tangent of 23 is equal to x. And we can use our calculator to find that the answer is going to be equal to 3.8. So lots of good examples so far of solving for trig. We are now on the last two examples of doing this just with straightforward kind of similar problems. So in number 5 in the bottom left, we are looking at a 23-degree angle in the bottom left, making this the opposite side and the hypotenuse side. So we have sine of 23 degrees is going to be equal to the opposite over hypotenuse. And we can find that answer pretty easily by just multiplying by 28 on both sides, giving us 28 sine of 23. And that is going to be equal to x. And we find that answer using our calculator. And we get 10.94, which will round down to 10.9. Last problem on the front before we do finish with a multi-part problem on the back. We have our x value is at the top of this triangle, and then our 10s on the side with our 68-degree angle being right here. So we have an opposite and we have an adjacent side, making it tangent. So we have the tangent of 68 is going to be equal to 10 over x. And now we can just follow our steps from before, putting it over 1 and then cross multiplying with 1 times 10, x times tan of 68. And set that equal to 10 times 1, or just 10, and then divide both of those sides by a tangent of 68 so that our x value is 10 over the tangent of 68, meaning that our final answer for number 6 is going to be 10 divided by the tangent of 68, or 4.04. Or just 4.0 if you round to the nearest tenth. That wraps up these 6 problems. So let's flip to the back, and we can see that we have a problem in number 7 where we are going to be working on these two problems, 7a and b. And we're basically on working through it in that we have to find more than one side of our triangle. So that is going to be a little bit trickier, but it's using the same steps we've been using so far. So depending on what you're doing, you could find some answers in a couple different ways for these problems, and you'll kind of experiment with it as you're on your own as you start to work through these. So now I have 24-degree angle. And so the first thing I could think about would be, well, x is the opposite side, and 35 is hypotenuse side. So I could do sine as my first part. Sine of 24 is going to be equal to x over 35. And then multiply by 35 on both sides would give me sine of 24 is going to be equal to x. And then I would put that into my calculator to find my x value. 35 sine of 24 degrees is 14.2. And I'm going to leave that as kind of a 14.236 because we might need that x to find y. So now that I know x, I could do use that x to find my y value, or I could do, so basically that y is the adjacent side. So I could do cosine of 24 is y over 35. And so that's probably the easiest way here. But with the next problem, we'll kind of do it. Actually, let's just use the x value. So our x value, so let's say we want to use our x for our next problem. So we could do the tangent of 24 degrees would be equal to opposite, which is our x, which is our new value right here. So that would be 14.236 over our missing y value. So now, like before, we're putting that over 1 and cross multiplying so that I have tangent of 24. And that is going to be equal, our y times the tangent of 24. That's equal to 14.236. And that means that our y value is going to be 14.236 divided by tangent of 24, which ends up as 31.97 for y. And you could try this a couple different ways and get to those same answers for x and y. So let's approach B a little bit different to show the variety of approaches that you can use in problems like these. So the first thing I would note is that we have a right angle here and then a 51-degree angle. So I could take that 51-degree angle, add it to 90, that's 141. There from left from that will be 39 degrees. And that means that I have 39 degrees left of my 180-degree total triangle. So now I can use that 39 degrees to find some missing answers. So if I want to think about the easiest way to approach this problem, what I would probably do is try to find my x value first. So I could use the 13 as my opposite side and the x as my adjacent side. So now I would do tangent of 39 degrees would be 13 over x. And we can cross multiply again and get tangent of 39 times x is going to equal to 13. And then I have x is 13 over the tangent of 39. My answer from that ends up as 16.054, approximately 16.054. So that's my x value. And now we have both legs of a right triangle using our trig functions. So something that you might be thinking is, well, if I have two sides of a right triangle, I can use the Pythagorean theorem to find the hypotenuse side. which basically is just going to be ending up as 13 squared plus our new x squared that we just found is going to give us our unknown y squared. So we can write it as 13 squared plus 16.054 squared from our x value over here. That is going to be equal to y squared. So we can now add up the numbers on the left side of that equation. 13 squared plus 16.054 squared equals 426.731 equals y squared. And the square root of that answer we just got ends up as 20.66. 20.66 equal to y. And that is our second problem of finding two unknown lengths of a right triangle. We've kind of looked through all of the applications of using trig to find unknown sides of right triangles. And we've seen all the kind of variety of algebra that you might be asked to complete to do this sort of topic. And that concludes this video of using trig to find unknown sides. Thank you for watching.